Hi guys, in this video we will study complex numbers. So let's go through the problems and introduce complex numbers. Imagine you are solving this equation x squared plus 1 is equal to 0. So we can take the 1 onto the other side and we can say x squared is equal to negative 1. Now if we square root both sides, we have to say plus minus. X is equal to plus minus the square root of negative 1. And you know the square root of negative 1 does not exist in real numbers. So we introduce complex numbers. We say that is equal to plus minus I. So what's the value of I? I is equal to square root of negative 1. In other words, what is I squared? I squared is equal to negative 1. Remember that you have to know this basic rule of complex numbers. Now, remember, the answer that we solved is complex. So x is an element of complex numbers, right? It's a special symbol C. It means complex numbers. Now, moving on to the next question. We want to simplify complex numbers. So if you are doing simplification of complex numbers, remember you need to do products, multiply them out, right? Because it's two brackets with two brackets, you will end up with 4 terms. So 3i times 2 is 6i. 3i times minus 5i is minus 15i, right? Squared. Minus 15i squared. 3 times minus 5 is minus 15. I times I is I squared. Minus 1 times 2 is minus 2. And minus 1 times minus 5i is plus 5i. So what do we have? We have 6i plus 5i is 11i. And we got minus 15i squared. But remember, I squared is negative 1, right? And then minus 2. So what we get? Positive 15 minus 2 is 13, because negative 15 times negative 1 is positive 15. Positive 15 minus 2, those are like terms. So that's 13 plus 11i. I will show you how to do it into the calculator. So you need to put your calculator on complex mode. So you go to mode and you go to complex, option 2. You type this into the calculator, square root, open bracket 3i. The I button is here. Minus 1, close open bracket, 2 minus 5i. And see what answer we get. We get 13 plus 11i. Now, it's important how you write complex numbers. The complex number is supposed to be written in the form a plus bi. Every complex number must be written in this form. A is the real part and b is the complex part. That's the real part and that's the complex part. Now, moving on to the next question, remember 3i minus 2 and 3i plus 2. So if you remember from basic simplification, does a plus b into a minus b, that basically becomes a squared minus b squared. That's difference of two squares. So we're going to square the 3i, so you get 9i squared minus 2 squared is 4. Is it here? We squared the 3i, we got 9i squared, and we squared the 2, we got, and remember, it's difference of two squares because this is 1 minus, 1 is minus, 1 is plus. 9i squared, I squared is negative 1, so we're going to get negative 9 minus 4, and the answer is negative 13. So this is a nice, beautiful problem because you're multiplying out two complex numbers and you're getting a real number. Great. Now, remember the rule for expanding. So we say 5. What's the rule for expansion? What is a plus b squaring a binomial? Is a squared. The middle term is very important, is 2ab, right? And b squared at the end. Now, but we have a minus. So minus is followed with a minus only in the center, right? So if you're solving this equation, you're going to get 5i squared, which is 25i squared, minus 3 times 5 is 15 times 2 is 30i, plus 9, because we need to square the negative 3. 25i squared is negative 25, because I squared is negative 1, minus 30i plus 9. Now, minus 25 plus 9 is negative 16 minus 30i. Let's check our answers. So we go back to the calculator. So we had 3i minus 2 for the previous sum. And we got 3i plus 2. So we have an answer which is negative 13. That works. The other one is squared. Let's delete all this. It's basically 5i minus 3. Just editing 5i minus 3. So what answer do we get? 5i minus 3. Minus 16 minus 30i. So we are on the right track. Let's move on. Make sure your calculator is in complex mode. Now, what are complex conjugate? The complex conjugate of a plus bi is a minus bi. So only the complex part becomes opposite sign, right? So that's a complex part. So it becomes negative bi. So minus 2 plus 3i becomes minus 2 minus 3i. Root 3 plus I becomes root 3 minus I. Minus 1 plus 4i becomes minus 1 minus 4i. 3i minus 4, be careful. This is the complex part. So it becomes minus 4 minus 3i. Just rearranging. Remember, it's minus 4. This is minus 4 plus 3i. So that will become minus 4 minus 3i. Next one is I minus 2. It's the same thing as saying minus 2 plus I. So this will become minus 2 minus I. This is A minus BI. So it does become A plus BI. I hope you understood that. Just the complex part becomes negative. It's already negative. Make it positive. Moving on to writing the complex number in the form A plus BI. So we want to write a fraction in the form A plus BI. So what do? We say we have 2 minus 3i divided by 3 plus 2i. So we're going to multiply it by the conjugate. That's why we did conjugate before, to simplify complex numbers. So we're going to multiply by 3 minus 2i, conjugate of the denominator, over 3 minus 2i. Whatever you multiply, remember that cancel out, that is 1. We're not changing the value of the fraction. The next step is to multiply out the denominator. That's difference of two squares. 3 times 3 is 9. Plus 2i minus 2i is minus 4i squared. Right. Now the top is 2 times 3 is 6. 2 times minus 2i is minus 4i. Minus 3i times 3 is negative 9i. Minus 3i times negative 2i is plus 6i squared. Now, remember I squared is negative 1. So we got 6 minus 4i minus 9i is minus 13i. And I squared is negative 1, so minus 6 divided by 9 minus 4 plus 4. Minus 4 times negative 1, so plus 4. So plus 6 minus 6 cancels out. We got negative 13i divided by 13. So the answer is just negative I, because the 13 and the 13 cancels out. So now let's check if this answer is actually negative I. So you're going to use a calculator, right? So open brackets, no brackets, 2 minus 3i over 3 plus 2i. See, the answer is negative I. I hope you understood that. Moving on to the next question. Now, what is a complex number? A complex number is just a dot in the complex plane. So this is the complex plane where we have the real axis and we have the imaginary axis. So the real axis is the real part and the imaginary axis is the imaginary part. So this is I, on top is 2i, and this is 3i. Okay. Now, we got 1 plus 3i. So 1 plus 3i is that value there. That's a dot. That is Z1. Minus 3 plus 2i. Minus 3, minus 1, minus 2, minus 3 plus 2i. So you get that. That's the point, Z2. Right? Then Z3 is minus 3 minus 2i. Minus 3 minus 2i is right here, directly below. But if you notice that Z2 and Z3 are complex of each other, complex conjugates of each other. Now, what does a complex conjugate mean? The complex conjugate means it's just a reflection across the real axis. So those values are the distances between the real axis and the complex number are the same. That's what a complex conjugate means, right? Next one, what is Z for? 3 minus I. So 3 is here, negative I is down. So this is the location of the point Z4. Pretty simple, right? Let's move on. What is a modulus? The modulus of a complex or absolute value of a complex number. Now remember, complex number is written in this form: Z equals A plus BI. So this is a real axis, and that's the imaginary axis. So this is a 90. So just say if this is a complex number here, the distance from there to there on the real axis is A, and on the imaginary axis is B. So what is the complex conjugate? It's just this distance over here. So we just call it absolute Z. So absolute Z is equal to the square root of, it's Pythagoras basically, A squared plus B squared. That's it. Square the A, square the B, and take a square root. That is the modulus. It's the distance between the complex number and the origin. That's what a modulus is that distance there. Now, moving on to the next concept, not really a concept, solving the equation. Let's find the roots of this equation. In order to find the roots of this equation, we need to use a quadratic formula because we can't clearly factorize this. But if you use your equation solver mode, go to 5 and option 3, you can see A, B, C values. A is 1, B is 1, and C is 1. If I solve this, see what answer I'm getting. Negative half plus root 3 I over 2 and negative root 3 over 2I. So let's get to the same answer. How we get to the same answer? We use a formula x equals minus b plus minus the square root of b squared minus 4ac divided by 2a. That's the quadratic formula, right? Now remember, a is 1, b is 1, and c is also equal to 1. So let's substitute everything into this quadratic formula. So negative b will be negative 1 plus minus the square root of b squared will be 1 minus 4ac. 4 times a times c, 4 times a times c is just minus 4, divided by 2 times 1, which is 2. So we got negative 1 plus minus the square root of negative 3 over 2. Now the square root of negative 3, the square root of 3 is root 3, but the square root of negative, now how do we work out square root of negative 3? Square root of negative 1 times 3. So the square root of 3 is root 3, and the square root of negative 1 is I. So in future, the square root of negative is just I, okay? So now we can simplify this. We got negative 1 over 2 plus minus root 3 I all over 2. Now, wait, let's write it like this in fraction, and then we'll split it up. So we got negative 1 plus minus root 3I all over 2. It's the same thing as saying splitting it up like this way, and this way. So we got negative 1 over 2 plus minus root 3 over 2I. So there are two answers here. One answer for x is negative half minus root 3 over 2I, and the second answer is a conjugate. It has to be plus root 3 over 2I. Now, nice question. Let's look at the next question. Given one root of a quadratic equation is 2 minus 3I, find the equation. So obviously, if one of the root is 2 minus 3I, the other root has to be 2 plus 3I. So we got two answers, x equals 2 minus 3I or x equals 2 plus 3I. Bring the 2 over, bring the 3 over. So we got x minus 2 plus 3I, put it in brackets, and bring that over and bring this over. Put it in brackets, make it equal to 0 because we need to find the equation. So x minus 2 minus 3I. Now what you notice here is this part over here and this part over here are A, and this part here and this part is B. It's like A, B. So this is common and that is common. And this part and this part is also common. So we have one plus, we have one positive and one negative, right? We have a positive and we have a negative. So this difference of 2 squared. So it's basically x minus 2 squared minus 3I squared, which is equal to 0. Now expand this, that is x squared minus 4x plus 4. We have done it before. And then minus 9I squared is equal to 0. So we got x squared minus 4x plus 4 plus 9 because I squared is negative 1. negative 1 times negative 9. So now we got x squared minus 4x plus 13 is equal to 0. So this is a quadratic equation that will give us these two answers. Let's double check it. So you go to mod, that's 1. The value of b is negative 4, and the value of c is 13. And see, we got 2 plus 3i and 2 minus 3i. And they told us one of the root is 2 minus 3i. That will always be the case, okay? Hope you guys are understanding. Let's move on to the next question. So now we have practice questions. Great. So what is the sum of 3 plus 2i and its complex conjugate? Very important. So we want to find the sum of 3 plus 2i and its complex conjugate. Sum means add up what? Add up 3 plus 2i, this complex number, and the second complex number, which is 3 minus 2i. So if you add them all up, you get 6 plus 2i minus 2i cancels out because this is a conjugate. Remember what a conjugate is? The complex part becomes negative, or the negative, if it's negative, it becomes positive. So what we have, the answer is just 6 because plus 2i minus 2i cancels out. So the answer is 6. Moving on to the next part. We want to multiply out these two complex numbers. So 2 times 1 is 2. 2 times negative I is negative 2i. 3 times multiply these two out is plus 3i. And multiply the last part out plus minus 3i squared. So you got 2 plus I plus 3. Why plus 3? Because negative 1 times negative 3. So you got 5 plus I. So where's 5 plus I? Answer is A. What is a modulus? What's the modulus of this complex number? It's easy because you just need to square this part and this part. So the modulus absolute z is equal to square root of 4 squared plus 3 squared. Actually, it should be negative 4 squared, but so it should be negative 4 squared, right? So either you still get the same answer. Because you are squaring, you can just take the numbers like absolute and put it in there and just sum them up because you are always finding the radius, right? So that's 16 plus 9, which is square root 25, which is equal to 5, right? The answer is 5. Moving on to the next part. What is the quotient? 1 plus. So you're going to multiply by the complex conjugate, which is 2 plus I and 2 plus I. Now, 1 times 2 is 2. 1 times I is I. I times 2 is 2I. And I times I is plus I squared divided by 2 minus I, 2 plus I, that's difference of 2 squares. So that's just 4 minus I squared. Now, we got 2 plus 3I squared is negative 1. And then that's 4 plus 1 because that's negative times negative 1 plus 1. So now you got 2 minus 1, which is 1, plus 3I all over 5. So what's the answer? 1 plus 3I all over 5. Where's 1 plus 3I all over 5? So the answer is A again. Next one. Quadratic equation. We want to solve for this. So you're going to say x squared is equal to negative 9. X is equal to plus minus the square root of negative 9 plus minus, what's the square root of negative 9? Square root of negative is I, and the square root of 9 is 3. So the answer is just plus minus 3i. 3i, that one. Moving on to the next question. Combined operation. So we want to find the sum, or see 2 times z minus w. So what is 2 times z minus w? 2 times what is z? 1 plus 2i minus what is w? 3 minus I. Right? So now you're going to multiply 2 times 1 is 2 plus 4i. Take the 2 inside. Minus 3 plus I. So what we have? 2 minus 3 is negative 1. 4i plus I is 5i. So the answer is negative 1 plus 5i. So A. Moving on to the next question. Z is equal to 4 minus 3i. What is absolute Z? Now remember Z with a line, okay? Is a conjugate. Modulus is absolute and Z with a line is a conjugate, right? So if you want to find the absolute of the conjugate, but the number is this. So what's the conjugate first? The conjugate is the Z with a line. So conjugate of Z is 4 plus 3i. And now you want to find the modulus of this. So the modulus is the distance. So the square root of 4 squared plus 3 squared. So that is 16 plus 9 square root of 25, which is 5. So the answer is 5. So look, in order to find the modulus of the, remember, we can make a conclusion now. The modulus note, we just proved that the modulus of z is basically the modulus of the conjugate. It has to be the case. Because if you're looking at the diagram, remember what I told you, uh, is directly across. So if you're going to draw a line like this from here to there, and then draw a line like this from there to there, it's the same distance, it's the same radius, okay? Going back to our problem. So we just proved that modulus of z is the modulus of the conjugate. Find the product. 5 plus I, 5 minus I is 25 minus I squared. And you know I squared is -1. So that's just 25 plus 1, right? Which is 26. Moving on to the next problem. Quadratic equation with complex roots. Now, let's see. We want to solve for this. So how are we going to solve this equation? We have to use the quadratic formula. So x equals minus b plus minus the square root of b squared minus 4ac divided by 2a. Now, remember, a is 1, b is -4, and c is 13. So x equals, what is minus b? Minus b is 4, because negative, negative, minus b. B is already -4, so minus b will be 4. Plus minus the square root of, what is b squared? 16. Minus 4ac, 4 times 1 times 13. 4 times 1 is 4, times 13 is 52. Divided by 2 times a, just 2. So I've got 4 plus minus square root of 16 minus 52. I think you get 36, -36, okay? Divided by 2. So 4 plus minus, remember -36, square root of 36 is 6, and square root of negative is I, divided by 2. Now you can divide by 2 on top, and you can divide by 2 at the bottom, because this is a complex number, right? So you can divide by 2, divide by 2. So if you divide the top by 2, 4 divided by 2, you have to divide each term by 2, basically. 4 divided by 2 is 2. 6 divided by 2 is 3. 2 divided by 2 is 1, all right? So 2 plus minus 3i. Where's 2 plus minus 3i? So answer is A. Moving on to the next question. Now, we want to check if that's actually the answer. So let's put it into the equation solver, mode 5, and you're solving the quadratic equation. So select option 3. So x is the coefficient of x squared is 1, coefficient of x is -4, and the coefficient, and the constant is 13. See what answer you get? 2 plus 3i and 2 minus 3i. So the answer is correct. Quotient using, so we want to simplify this. So in order to simplify this, we're going to multiply by the conjugate. So -2i, -2i, -2i. So what's the answer here? 5 times -2i is -10i. And 2i times -2i is -4i squared. Right. So I squared is -1. So we got -10i. I squared is -1. So -4 times -1 is just 4. So -5/2i. Where's -5/2i? -5/2i. Or -5i/2. Same thing. The I can go on top. You can't put the I in the denominator, of course. -5/2i. There's lots of answers with -5/2i. -5/2i. So it's both these two options. Yeah, because that's also a negative, that's also a negative. -5/2i, and that's so these and right. So both these answers are the same. So this should have been a positive there. So let's just select B in this case, right? Next one. Yes, we want to solve for x and we want to solve for x and y. How are you going to solve for x and y? This is a real part of the complex number. Remember, there's a complex number on the left-hand side and a complex number on the right-hand side. So equate the real part to the real part and the complex part to the complex part, right? So the real to the real, equate the real part to the real part and the complex part to the complex part. So I'm going to highlight it, right? And highlight the other one, right? And highlight -7. So the real to real is x plus 2 is equal to 4. So x is equal to 2. Y minus 3 is equal to -7. Add 3, y is equal to -4. So x is 2, y is -4. X is 2, so the answer is A. Moving on to the next question. We want to add the absolute of z and an absolute of w. So 12 squared plus 5 squared. So that's 5, 12, 13 triangle, right? So absolute of z is square root 12 squared plus 5 squared plus absolute of w is square root 3 squared plus -4 squared. So that's going to give me 13. And that's 3, 4, 5 triangles. So that's going to give me 5. So 13 plus 5 is 18. Complex quadratic. One root of a quadratic is 4 minus I. If the equation has a real coefficient, what is the other root? So 4 minus I is 4 plus I, the conjugate. What is the other root? The other root has to be the conjugate of -I, which is positive I. So 4 plus I is the other root. Now, similar question. This question is continuing here. We just want to find the equation. What is the equation? So x is equal to 4 minus I, or x is equal to 4 plus I. Bring the 4 over, the I over. So you got x minus 4 plus I, brackets, x minus 4 minus I. I hope you're understanding how we're getting that. Bring the 4 over and the I over. So now you're going to take this part as one part, and the second part as a second part, and make it equal to 0 because we want to find the equation. Now you have x minus 4 all squared minus I squared is equal to 0. So you got x squared minus 8x, squaring a binomial, plus 16. Now I squared is already -1. -1 is plus 1 is equal to 0. So x squared minus 8x plus 17 is equal to 0. That's the equation. Let's check if this equation works and if you're getting these two answers. Right, so mode 5, 3. So we got 1, -8, and 17. Let's see, the answer is 4 plus I and 4 minus I. We just have to work backwards to get to the equation. Next part. All right, so we end this, no, we still have, so I'm going to skip a few examples because you already know this. Okay, the imaginary part of the complex number. What is the imaginary part of the complex number? Imaginary part of the complex number is 2i, right? So it's the entire term. Next question. Find the value of I to the power 15. How are you going to find I to the power 15? We already know I squared is equal to -1. So divide this by 2. So you're going to get the answer is equal to, remember, I to the power 15 is I to the power I squared to the power 7. Because when you divide this by 2, you get 7 and remainder 1. So 2 times 7 is 14. 14 plus I to the power 1 is 15. So I squared is -1. -1 to the power 7 times I. Okay, so we're going to get negative I, because -1 to the power odd is negative. So negative I. Find the value of I to the power 46. If you divide this by 2, you'll get 23. So that's I to the I squared to the power 23. Okay, 23 times 2 is 46. So both of them are equivalent. I squared is -1, and to the power 23 is also odd number. So it's just -1. Hope you guys understood that. Next question. What is this? The value of square root of -49. The square root of -49 is basically the square root of negative is I, and the square root of 49 is 7. So you should get 7i. We want to find the value of this. We're just adding up two complex numbers. That's 6 plus 3i minus 2 plus 4i. So now 6 minus 2 is 4. 3i plus 4i is plus 7i. So 4 plus 7i. Next one. Find the value of a if this is the case. 5 equals 5. So you can take out 5 from both sides or equate 5. So you're not solving anything. And a is equal to negative 12. So easy, right? Equate this to that. So a is just equals to negative 12. It's like just equating both. The product of 2 minus 5i and 4 plus 3i. So 2 times 4 is equal to 8. 2 times 3i is 6i. Minus 5 times 4 is negative 20i. Minus 5 times 3 is negative 15i squared. I squared is negative 1. So 8 plus 6i minus 20i is negative 14i plus 15. 8 plus 15 is 23 minus 14i. So that's your answer. Moving on to the next question. The value of 7 plus 2i over I. So 7 plus 2i over I multiplied by the complex conjugate, negative I over negative I. Right, that's a conjugate of the complex number I. Only the complex part takes a negative. So 7 times negative I is negative 7i. Negative I times 2i is negative 2i squared divided by negative I squared. Now, negative I squared is negative times negative 1. So the denominator falls away, right? Because this value of this is already equals to 1. So we don't need the denominator. So the answer is, remember, minus 2i squared is positive 2. So you got 2 minus 7i. So that one. The quadratic equation has, what does the quadratic equation has? So what determines the nature of the root is we have minus b plus minus the square root of b squared minus 4ac divided by 2a. That's a quadratic formula. Let's look at this b squared minus 4ac. If you observe b squared minus 4ac, that's called the discriminant. The discriminant, this part is called the discriminant, right? If the discriminant is positive, so delta or discriminant is b squared minus 4ac. If it is negative, it will always have two complex roots. It will have two complex answers or roots, okay? And if d is equal to 0, b squared minus 4ac is equal to 0, then it will have a repeated root. In other words, you'll only get one answer, but the root will be repeated, multiplicity 2. If d is equal to positive b squared minus 4ac is greater than 0, then we have two answers, two real answers, okay? Now, this can be real answers in two forms. It can be a form of perfect square. If this b squared minus 4ac is a perfect square, then you will get rational answers, okay? And the answers will be in like fraction form. But now, if it's not a perfect square, then you will get irrational answers. Then the answers will be two irrational roots, irrational. Irrational, like you'll get square root of 3 in your answer, or root 5 or root 7, right? Now, this quadratic equation, let's find just the d value. D is equal to b squared minus 4ac. B squared is negative 2 squared minus 4. A is 1 and C is 5. So what we are having here is 4 minus 20 is negative 16. Negative 16 is less than 0. So we have two complex roots. The answer is C. Right? So we have to have two complex roots according to this theory. And the last question you can solve on your own. I'm just going to put it on the calculator. And okay, let's just solve it. 5 minus I, 1 plus 2i. You're going to multiply by the conjugate, 1 minus 2i, and 5 plus I. So multiply everything out. 1 this is 1 minus 4i squared. I squared is -1, so plus 4. 5 times 5 is 25. Plus 5i. Wait a minute. Why did I multiply by 5 minus I? That's incorrect. It should be 1 minus I. Yeah. 1 minus 2i. We need to multiply by the same thing, right? You have to multiply it by the same conjugate. So it can cancel out, become 1. You're not changing the fraction. So 5 times 1 is 5. 5 times minus 2i is minus 10i. Minus I times 1 is minus I. Plus 2i squared. Now remember, 2i squared, that's right here. 2i squared is -2. So 5 minus 2 is 3. Right, so we got 5 minus 2, which is 3. Negative 10i minus I is minus 11i and over 5. So this is over 5 and that is over 5. So 3 over 5 minus 11i over 5. 3 over 5 minus, right. So this brings us to the end of the session.